Okay, let's take a look at how to graph an absolute value function. Now, in this case, this is still going to make a set of lines. It's just they're going to have a slightly different feature than your normal linear graphs. And if you ever get stuck on something, there's always an old school way to do this. You can always do this. And just pick some points. Well, let's see, what if x equaled 0? Okay, well, let me try that one out. And I put in 0 up here, and I get 0 minus 3 minus 5. And the absolute value of negative 3 is 3, and 3 minus 5 is negative 2. So negative 2. And you just keep on going. Okay, what if it's 1? What if it's 2? What if it's 3? And just keep on picking points. Now, that takes a long time. And the problem is, you might get 2 or 3 points here and think you've got it figured out, but you really didn't find out the special place on this graph. And I'm just going to give you a little hint here. Okay, all absolute value graphs, graphs that have the absolute value with a variable inside, are going to have the same type of features. They're all going to make this V. There's going to be a certain spot we call the vertex where it just turns around and goes back the other direction. And the reason is, remember, absolute value always comes out to be positive. So you're going to hit a certain point where the answers turn around and go back the other way to keep it a positive value within this piece of the graph. Okay. Now, could it be like this? Absolutely. You could get an upside down V. All you would need is a negative number in front of the absolute value sign. Could it be really wide and flat? You bet. It all depends on what the number in front of the absolute value sign is. Could it be really steep and narrow? Sure. Okay, they're all going to be V's. We just have to figure out kind of what they look like. Okay, now let's figure out what's the best way to attack this. Okay, the best way, in my opinion, is to first find that turnaround point. Find the vertex. Okay? And this is really pretty easy to do. Okay, it takes just a tiny bit of thought. Look at the inside of the absolute value bars and ask yourself, what makes that stuff equal 0? What x value can I put in there to make that whole amount be 0? And the answer in this case would be 3. Okay. Now, if I put 3 in there, I get this for a result. What is that? Well, it's 0, like we just said. 0 minus 5 is negative 5. Okay. So there's my vertex. 3, negative 5. Which is right about here. Okay. Now, how do we know what the rest of it looks like? Well, there's some shortcuts we're going to work on in class, but the surefire way to know exactly whether you did this right or not is to pick some other points. Okay. So, for example, if we know 3, negative 5 is our vertex, let's put in 2 and 4, and we should get the same y value for these if we did it correctly. It's a good way to test to see if your vertex is in the right spot. So let me try 2. Absolute value of 2 minus 3 minus 5. I just need to compute that. 2 minus 3 is negative 1. And the absolute value of negative 1 is 1. 1 minus 5 is negative 4. Now I should get that same answer on the bottom if I did my other math correctly. Okay, so let's try that out. 4 minus 3 minus 5. 4 minus 3 is 1. The absolute value of 1 is 1. 1 minus 5 is negative 4. Okay, let me find those spots. 2, negative 4. 4, negative 4. And what do you know? I've got a V for my graph. Okay, so that's how you go about doing it. Now, are there some shortcuts? Absolutely. There's ways in class we'll talk about figuring out how steep or narrow they are, how wide or flat they are, how they move around on the page a little bit or flip upside down. But that's your base way of going back to figuring out where these graphs are and what they look like.